In this video, we're going to talk about AugerScan and Auger technique only, not XPS. So first thing we'll do is we'll go through all these pull-down menus, and then we'll look at the icons, which are grayed out right now mostly, and then we'll talk about the help. So step number one is when you open AugerScan, it should look something like this. There shouldn't be an error message that pops up that says no boards found. If you see that little error message, that little dialog box pop up and it says no boards found, that means you're probably not running as admin, or maybe the 147 interface unit is off, or you might have a problem with the drivers related to the RBD PCI card, which fits in the computer and then talks to the 147 interface unit. The 147 interface in turn talks to all the different components on your system. So first of all, we've got File, New. You have a survey as a wide scan. A multiplex is a series of narrow scans. Depth profile is a series of narrow scans plus sputtering, so you can see changes in the elemental composition versus depth. Alignment is used primarily for an elastic peak, which is used to set the position of the sample with respect to the analyzer. And three-point profile is not used anymore, but I could tell you what that is. It's a depth profile normally has each element has maybe 20 to 40 points, and a three-point profile just takes 3 points: the highest point, the lowest point before the peak, and the lowest point after the peak. And then it interpolates just to give you a peak-to-peak height change. So where that's useful for is if you were doing a continuous sputtering and you want a lot of elements, like maybe 6, 8, 10 elements, and you just want to see the general trend in the peak-to-peak height. That could be useful. But in general, most people are not going to use the three-point profile. The technique is going to be AES in this case for today's lesson, but if your system was so equipped, you could also run XPS or SIMS, and some systems have all three of these techniques on the same systems. File, Open. You could open a survey or some other data set. Okay, there's Open. File, Close, of course, we'll close it. Save, we'll save any changes that you made to the file. Save as, you can save it as a new file name. Email is something that we put in the program. This AugerScan's been around for a long time, since the early 90s. And that's when we added this email feature, which is really not used at all today anymore. You would just use a memory stick. But at the time, it was useful. Import is for importing older versions of our software. Export is text. What that does is it basically takes the data, rather than seeing it like you see it here now, you see the actual peak shapes and the height of the peaks. Instead, it would simply be two columns, EV and count. And so you could then export that out and read it in with something such as Excel, if you wanted to make a chart in Excel or do some other data massage. Export all allows you to select multiple files at the same time. Export to quasis, export all to quasis. Quasis is a program that was used primarily for XPS data massage functions. You don't really see it much anymore, but it was popular back in the 90s. Export to multipack. If you have a PHI system that was running on the PHI software before they upgraded to AugerScan, then they may be using multipack to do data massage. And so in that case, you would have to export from our software to be able to read it into multipack, and that's what this function does. Mark track. What this allows you to do is, see, it gives you a cursor down here with the counts as I move this line across. And then if I were to hit a peak, like let's say over here, for example, that might be argon at 216. It's pretty small. I'll just reselect oxygen. I'll just show you. If I get close to the oxygen peak, and now if I hit the left mouse button, the right mouse button, there, I just tapped it. Now it shows up and I would say select oxygen, for example, cancel. Let's pick a peak here. This is the peak where I'm at. I'll just tap it. And okay, that's close to nickel 1. Rather, that's nitrogen. I'd say okay. There's really no nitrogen. It's picking up a little bit just because of the noise. So mark track gives you the positions of the peaks, but it also gives you what we call markers. So the markers give you the peak that's selected, like for example, here it's using, this peak is selected, the 920 copper peak is shown here, CU1 is selected, and if it's got the little check mark, then that's what's used in the atomic concentration. So you only want to use one peak. Like say, for example, this is copper, 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 and even this peak down here is copper. You don't want to put atomic concentration values on all those peaks because then you'd have to add them up. So you just pick the largest peak generally, and then use the atomic concentration sensitivity factors will be used to do the calculation of basically peak height times the sensitivity factors divided by all the elements that you have to come out with a total of 100%. So let's see what we have here, for example. If I take my nitrogen and I uncheck it and say OK, see now it's still marked, but it doesn't show up in the atomic concentration table. So that's edit mark track and edit markers. The thing about markers as well is you can load and save these. So if I'm doing a lot of surveys with the same elements all the time, I can save that data set, that marker set rather, and then I can just basically load that up so I don't have to sit here and pick these peaks each time. If I'm doing the same data sets over and over and over, I just do it once and then save that. Another thing I can do here is I can remove all. Okay, and let's delete our atomic concentration. So now I'll show you again. If I come over here, get to the bottom of the peak, sorry. There we go. Okay, yeah, this screen recorder is kind of goofing up my the functions of my mouse, and so it's not working. But you basically you pick the lower part of the peak, and then you hit the right click on your mouse, and you get this message. And what it'll do is it'll pop up. This dialog box pops up, and it says, okay, if there were more peaks within that range, they would show up. But it picks what it thinks is the closest one. So I would say, okay, copper. So let's try the same thing over here. There we go. And here we'll say carbon. And then I'll come to the bottom of the peak here. Yeah, this mouse is just really giving me a hard time. This is crazy. Fucking piece of shit. All right, I'm going to have to stop this and just fucking start all over. All right, what I'm going to do is remove all the markers, edit, markers, remove all. And now I got to figure this out and see if I come over here and select oxygen. There we go. Okay, so what I'm going to do now is I'm going to show you, I'm going to remove all the markers. So I'll go Edit, Markers, Remove All. Okay, and then we'll just highlight our little atomic concentration and delete it. So how do you select markers is you hit the little marker button and you come in and you want to be at the bottom of the peak like this. And then you click on your, then you click on your mouse button and it will pull up a table. And the table is going to try to pick the closest element that it has to your position. So it's not smart enough to go out there and find the actual peak. You got to kind of find it yourself. And the reason we did it that way was because when we first started designing this feature, a lot of customers told us specifically, don't let the computer automatically pick, because they would spend most of their time fixing the computer picks. And so it's easier for them to just select it themselves. Okay, so we have those selected. Now what we can do is we can turn the marker off, and this little icon over here is atomic concentration. And now let's take a look at View Options. Graph, show tick marks, annotations, create atomic concentration tables. Okay, I'll say okay for that. So now what we'll do is we'll revert to raw. Now, because you have to differentiate the data first before you can do atomic concentration. Atomic concentration, now it gives us our table. And let me click on that real quick, and we'll just change the font to a larger font and just an easy color like black maybe. Okay, there we go. So now we're back where we were. So we have our atomic concentration. This, by the way, is a low energy copper peak, and these are copper peaks up here. And so I'll have another more advanced video that will show you how basically to add these peaks into the element table. Okay, so that's markers. Select endpoints and endpoints. That's used for depth profiles. So let's do this. Let's open up a depth profile. File, Open, Auger depth profile. Okay. Now one of the tricks here is you can go Window, Display All Regions. It'll open up each one of the windows. All right, so what I'll do here is I will go ahead and close this down. I'll close this survey down, or I'll just minimize it actually. I'll go Window, Tile horizontally. So what this represents is it's a depth profile of chromium, nickel, and oxygen. And so this is the number of cycles that basically each cycle is basically take data, sputter, take data, sputter. And so if we do the same thing we do for a survey, is first differentiate the data. After that, now notice it's displaying a peak to peak over here. Now we can do atomic concentration, and we can see that basically it's about close to zero on the oxygen. So it's alternating layers of chromium and nickel is what this sample is. So let's talk about endpoints a little bit. Here's oxygen, for example, right here. Let's pick instead, let's look at chromium. So I'll click this, chromium is now highlighted. Let's go back to Edit, Select Endpoints is now available. And see if I select from here to here, it's going to take the highest peak to the lowest peak, use that value times the sensitivity factors to give us this table over here that gives us the height. What if I have two peaks that were really close together? Like, so for example, chromium and oxygen. Well, in this case, I'm going to just select from here to here. See, so now this peak is not used anymore, and see what a dramatic difference that did. There's my oxygen, here's my chromium. So my chromium went down quite a bit. Let's go a little bit more. I'll go from just say this section to this section here. You see what that did over here? It automatically updates the data set. So endpoints are generally going to be the widest points in the window, or like this, just, I don't have to be way out here like that. And you see that doesn't really change it very much. But that's what endpoints do. Endpoints are only available in depth profiles. All right, so that's that. Annotation. let's go back to our copper survey. Annotation allows you to write whatever you want to have, whatever text you want to have, whatever font, whatever color. You can do all sorts of things, whatever you want there, and you just say OK. And then you can just click and drag it wherever you want it to be. It'd probably say this is an oxide because of, because it got exposed to too much oxygen during the bakeout cycle or whatever. And then, so we can label these peaks. We can put text wherever we want to. If you want to get rid of it, you just highlight it and just hit the delete button. Element table, Auger. This is where the data is stored for these calculations for different peak heights on the elements. And you have 3 kV, 5 kV, and 10 kV for Auger, because basically what happens is at the higher you go in kV, the more high energy peaks you get. That is, they get taller, they get bigger. So like, for example, right now, if I undifferentiate this data, you can see that this low energy 62 copper peak here compared to the 920. The 920 peak is bigger, right? It's about maybe twice as big. This is because it was taken at 5 kV. If you have taken this at 3 kV, these peaks would be smaller and they'd be closer to the size of this peak. So it's more like 1-to-1 at 3 kV, 2-to-1 or so at 5 kV, and then at 10 kV this gets even higher. So 10 kV, this high energy peak would be really high relative to the low energy peak. All right, so that is the element table. So again, it's pretty much has everything default is set up, but you can go in here and tweak it a little bit if you find that your values aren't quite working out right. Maybe your analyzer has dirty grids or something like that. The transmission isn't quite what it's supposed to be. Insert new object, that would be for, like for example, if you had Auger map and you wanted to put a picture that you took, like an SCD map, you could put that picture in here. All right, so now view toolbar, you have the main acquisition and region selection. That's the main region selection and acquisition here. So you want to leave those on. I recommend you leave those on. Status bar, that's this little thing that's down here on the bottom, and if you're acquiring, it'll say, sweep 1 of 2 or whatever's going on. If it's the computer's doing something, the software is doing something, it says, okay, I'm ramping the multiplier voltage. It'll tell you that down there. So you want that status bar on. Zoom allows you to kind of zoom in and to get a closer look at the peaks. Let's do this here. I'll differentiate this. Okay, now let's go back to edit markers. Now remove all the markers. Okay. Now let's go back to view, up here, view zoom. And let's say I want to mark the bottom of this peak. What I can do is I can zoom, and you notice it's like a magnifying glass now. Click and drag, hold the left mouse button down while you're dragging, and then release, and it'll zoom in. Now I can come back here with my marker, and I can know for sure I'm on the bottom. Because you always want to mark the bottom of the peak. Okay, that's edit, view, zoom, restore, pops back out. So zoom in, zoom out. You can zoom in as many times as you like to, but when you zoom out, it goes all the way back to the beginning. So for example, view zoom. I'll zoom here. Now I can zoom again. But if I go view, restore, goes back to where it was. The data is double buffered. So you have view raw data and transform data. Here's my raw data, which was the N over E. And then here's view my massage data or transform data, where I differentiated the data. Cycles time, this is all, you see these are all grayed up because they only apply to a depth profile. So let's go back to our depth profile. Window, tile horizontally. Let's look at this one here. View. So this is showing us in cycles. We can also look at time. So that's how, so this is like 5 minutes or so per layer. And we can also look at depth. Whereas as long as it knows what the sputter rate is, which we tell it by sputtering a sample of known thickness, and then you can calculate what your sputter rate is, then it can you can put that in there so that it displays in angstroms. And if you had a really deep sample, it would display it in microns. Expand x-axis. This is just a little thing here if you wanted to add, let's say I put the timeout here. Instead of, it's at 38 minutes now. Instead of that, I'll go out to 60. What that does is it just compresses the profile up a little bit. It gives you some space over here if you wanted to put some text or a picture or something like that. View, expand x-axis. Let's reset to 1:1. Okay. View options. This is where you have all sorts of control over things like the line style. First of all, general, view survey regions in their own windows when acquiring. You want to check that, and then display previously collected data during survey acquisitions. You want to check those two. So what this does, this means basically if I acquired a survey, I'd see the data, and then when it starts the next sweep, the data, instead of being blue, it goes to like a light gray, but you can still see it. And then you see the next sweep coming on top of that. And so that way you can see if your counts are going up or down. And then viewing survey regions in your own windows when acquiring data, that's like if you're doing a depth profile or a multiplex and you say display all regions, it will display each region as it's acquiring the data. So if you don't select that, you'll have one window that'll show, you know, here's my carbon, here's my oxygen, here's my nitrogen. If you have this window selected, the carbon, nitrogen, and oxygen will all have their individual windows open at all times, and you'll see the data collecting, you know, when it gets to that region. Annotations, you generally want the tab width to be set to 10. You can create atomic concentration tables, display concentrations on markers. I'll turn that off. You could go out to 2 decimal points if you want. XPS multiplex table. Fonts, you can edit for the labels. Okay, this here, I'm going to make this up to 10 font, a little bit bigger. And the titles, let's go to 12 on those, okay. Graph, show tick marks. You can show the grid if you want to show the grid. I don't have that selected. Let's turn that on. And 0 baseline for depth profiles. Okay, see now there's the grid. Let's go back here to Window, Display All Regions. So here's a little trick on the grids. View, Options, Line Style. So here's my survey graph axis, my grid rather. It's dot, dot, dot. I'll change that to solid. Oops. There we go. Come on. Okay. And the color, I'm going to go really light, light, light. And then the width, we want to go as thin as possible, which I think that's where it is. Okay. Now say okay. Let's see what that does. See, now I still have the grid, but it kind of, the data kind of pops out in front. So the grid is there, but it's much lighter. It's not as evident. Okay. So that's view options. Annotations, you can set the default font size and colors and all that when you do that. And curve fitting is for XPS, so we won't talk about that. Okay, acquisition. Start basically means start the acquisition. That's the same as this green button over here, the green go button. Start starts it, stop just stops it at the end of the next sweep or cycle, depending on what it's doing. In other words, stop means I want to save the data. Stop now means I don't want to save the data. And that's the same as hitting the little red stop sign, which is grayed out right now over here, but this is actually stop now. And however, if you had been acquiring data for a long time and then you accidentally hit that, it's going to say, are you sure? It won't absolutely stop and you lose all your data. The stop now is useful, like if you're doing an elastic peak to set the data, to set the position of the analyzer with respect to the analyzer. You don't want to save that. So once you're done setting your elastic peak, then you're going to, you're just going to stop it. Continue is useful because what you could do there is, let's say if you took 10 sweeps and you found that your signal to noise wasn't quite correct, you want it a little bit better, you could give it another 10 sweeps. You can just continue to add more sweeps. Or let's say you're doing a depth profile and you get to the center point, especially for a scanning Auger system. You're doing a depth profile, you hit the interface of interest, you may want to pause the depth profile, save it at that point, and then go out in Auger map and maybe do multiple points or take an image or do an Auger map or something. whatever, and then say, okay, now I'm done with that data. Now I want to continue where I left off. Then you can just load that file back up, make sure everything is all the same in terms of position of the beam and beam current and distance and all that, and then hit continue, and it'll just pick right off where it left off. Acquisition settings, these are the settings for this analysis. So this started at 30, 1030, 1 EV per step. This was something where we must have been testing something. We let it run a long time, 101 sweeps. Okay. Edit. Edit, you got to think of the data like it's a Word document in a way. Let's say here, I'm going to say edit. I'm going to say, okay, I'm going to make this go 530. All right, boom, good. Okay, now let's say I want to go back. I want to undo that. Let's revert. Oops, see, I can't revert back to that. I edited that data, it's gone. However, think of this like a Word document. Maybe I did this deliberately, in which case now I want to save this new data set, say save as, or the way you can get out of this is you can just simply say, or I can save it as a new file name, of course, or I do want to save this as I just did it, or I can just simply say file, close, and say save changes, no. Now if I go back here, open it up again, it's right where it left off. Okay. Sample properties, that's used for most of the XPS systems where you have multiple, some of the XPS systems have multiple stages, multiple sample stages where you can program in a bunch of positions and just let it run. This system doesn't have that, so you're not going to use that. Auger systems don't. Okay, now we're back here again. New survey, new multiplex, new depth profile, new alignment, new technique, new 3-point profile technique. So these are the same things that we got to up here with file new. So there's more than one way to get to that. Technique is going to be AES. Acquisition options. Here's where you're going to want to say prompt to save after acquiring and load previous settings for multiplexes and depth profiles. So if you're doing a depth profile, you're generally going to do the same thing. You're going to compare one sample to another, most likely. And when you do that anyways, you can just have it, if you say new depth profile, it will load all the previous settings. So you don't have to sit there and reload everything individually. And then prompt to save after acquiring is nice, because what happens when it gets to the end, you get a little dialog box that pops up and it says, give me a file name. And so that way you won't forget to save something, and or you're less likely to overwrite another file. Because you could acquire a file and then write right over it. So, and then export, you can automatically export to ASCII. And you can sound an alarm when the acquisition is complete. We added that, again, that was in the early 90s. It was kind of cool back then because you could load a sound in, whatever you wanted. And if the lab was kind of noisy, you'd hear it when the acquisition was done. Generally, you're not going to use those. And then this is SIM, so we don't care about that. Okay. So data. Revert to raw data. Gets back to that. Edit raw data is a text editor. And so basically, you can go to a specific EV, and then you can modify the count, and then you can say, okay, and you can save it. So that's useful if you had, let's say you had perfect data that you were going to publish something. You had one little noise spike where it took a glitch or something. You could get in there and you could edit that out. So now we can differentiate, smooth, convert to counts. Our data is counts per second, so sometimes people want to know what the actual counts are. We go counts per second because you have to normalize the data before you can do the atomic concentration. So we just jump right to that. Shift is useful primarily for XPS, but let's say if you had an Auger and you had a little tiny bit of charging where it moved the peak just a couple EVs, you can compensate and shift the peaks to the right position. Okay, then a lot of these other ones here, these are all related to XPS, so we won't go into that. Atomic concentration, you notice that that's grayed out right now. That's because this data is not differentiated. If we differentiate it, now we go back to here, now atomic concentration is available. Atomic concentration is here, but it's also this little percentage box here. That's also atomic concentration. Data options. Differentiate, Generally 5 and 5 on the smooth. That's typical. You could add more smooth points or more differentiation, but all the handbook data was taken with these parameters, and so you probably want to keep those. List all Auger elements. I like to go plus or minus 15. So if you're looking for something like silicon and silicon oxide where there's a big shift, you can pick that up. Display marker box while tracking. In that case, it will display over here as you move the mouse. I don't personally like that, but if you want to try it, give it a shot. Basically, you check that box, and then when you do the markers, there'll be a little box that'll pop up over here that you'll see the peaks popping up and down as you move it. When marking an element, mark all of its peaks. Yep, we want to do that. And this is XPS. We don't care about that at this time. System, hardware properties. This is where you set up. Okay, general here would be for Auger, really nothing. The specimen stage and neutralizer, these kind of things. So you really don't have that for Auger. So we hit the AES tab, and this is where you can select your analyzer control, which for the most part is going to be 32150 or 72150 for most PHI Auger systems. You could also, some of the older ones have an 11500 or 20805 that uses an analog out, so you'd select that. Your V to F, your preamp is usually a 96A. Your ion gun control is usually an 11065. This you can select your multiplier control. And so basically you adjust these parameters to match the hardware that your system has. Multiplier properties, same thing. Auto EMS is checked. Here you notice that these numbers here, and I have a blog post on this, by the way, that you can find that explains how this auto setting, the multiplier thing works. But basically hit preamp defaults if you're not sure, and then these numbers will change. And so what this represents is, in the case of a survey, it's 800 kilocounts, and the maximum is 1 million counts. So basically, what it does is it ramps it goes to the end of the survey, because the survey, normally the background increases, right? And so it goes to the end of the survey, starts ramping the multiplier voltage up until it gets 80% of max counts and says, okay, that's my multiplier setting. But for the alignment, it's lower, it's much, much lower, because the peak is high for an elastic peak. And so therefore, after the peak, it drops down to 0. So in this case, it takes the counts before the peak. And so that's a lower number. But typically, what you're going to see is your multiplier voltage. This is the maximum voltage here, and this is the pulse count voltage. So if your Auger analyzer has both V to F and pulse count mode, it'll ramp the voltage up. But if it hits pulse count voltage before it gets to the normal count rate, then it's going to say, okay, pulse count automatically. And if your system doesn't have the pulse counter selected, then what you want to do is you want to put this voltage here higher than the maximum voltage. So in this case, I'll go 2500. And then I'll say OK. And that way, it would never go into pulse count mode, because the voltage would never get above 2400. OK, so again, this is all pretty standard. Gun properties. OK, gun properties, this is all just bookkeeping stuff, except for the sputter rate in angstroms per minute. If you change that, this is a global setting now. Let's say that you got your analyzer set up and you've calculated your sputter rate on silicon oxide, and you're using the same parameters on the ion gun all the time. Then you would want to put that value, whatever that sputter rate is, in angstroms per minute right here. And that way, every time you do a depth profile, it'll use this number. But you can always change it for each individual depth profile if you find that, oh, that's not correct, it's this instead. You know, it's actually 20 angstroms per minute, for example. Then we could say, okay, change that to 20 for that profile only. This is the global setting up here. And the other thing that's important is this is the global setting for, this is the beam voltage that it takes for doing the atomic concentrations. So if you have a manual system, in other words, not a scanning Auger system, which also has Auger map software, where that would get updated automatically, then you'll just have to set it. And in most cases, your data is going to be taken at 3 kV. If you have an old 11010 controller or an 11045, most of the data is going to be at 3 kV anyways, and so you just want to make sure. But if you're taking data at 5 kV, you got to change that to 5 kV here, so that the atomic, so that it selects the correct atomic concentration voltage. Okay. Calibrate analyzer, that should be grayed out. It's a feature we started to add specifically for XPS and Auger, I think, where it would automatically calculate and adjust the offset and gains to get those peaks to come in the correct position. Primarily for XPS, but it's a work in progress, and frankly, it's probably never going to happen. Diagnostics is something here. Oops. All right, I'm gonna hit this, and the program's gonna crash, and I'll have to open it back up. I forgot about that, since I don't have a 147 connected at this juncture. So I'll say OK. Okay, now I'm continuing. This is after I selected that. So System Diagnostics allows us to access parameters that you generally are not going to deal with. But it's a way, for example, we can write out commands based on the PHI calibration procedures and then see if the voltages are correct. Like for the analyzer control, it might say write out 16FF and then get 1000 volts, on a supply. We can use the diagnostics to check those calibrations. Sputter is a manual sputter timer where you can set it up and say, okay, I want to sputter for 5 minutes, and then hit start. And then it will automatically turn the ion gun on. Of course, you'd have to have your ion gun set up first with argon and emission and all that. But it will at least turn the beam on and off automatically, so you can use that as a little bit of a pre-cleaning. So ion gun control stage, all these things are grayed out because they don't apply. Automation is really not useful for Auger. It's more likely to where what you can do is you can set up a, say, like a survey, and then multiplex, and then a depth profile on a sample in XPS, and then move to another sample, totally different sample, and then repeat that process. You can set that up with automation. Batch feedback control did the same thing. That was way back before we had our own animation feature. We used some other program. So these things technically for Auger should be grayed out. Okay, so window, new window, tile, cascade, these are all, and arrange icons would be for moving, if you wanted to move these icons around a little bit. I don't know why you would want to do that, but here's how you do it. And now I could just click and drag and move this one over here, for example. Okay, or move it back where it was. Try to move it back where it was. Huh. All right, I'll just slam it over on the end here. See, this is why you don't want to do this. All right, let me pop it back up here. Okay, so that's tile horizontal and tile vertically. All these, standard Windows things for looking at the thing, at your stuff, at your windows. And then these are the windows that we have open here. Okay. Now, the icons here, we're going to blast through real quickly. They do the same things. So this, and if you hover over it, it should say, so that's new survey or new acquisition, open an existing one, save, import, export. I think that's print. Yeah, this is print. Oh, that's export. That's export all. Print. This is copy. This copy is text. Paste. Marker. Oh yeah, edit and remove markers. Select endpoints. Edit endpoints. Insert annotation. New survey. New multiplex. New depth profile. New alignment. Peak alignment. That is element table. Oh no, that was a 3-point profile. And then you have Auger, XPS, and Sims. And then here is, this is acquire, this is start, this is continue. This is stop at end is yellow normally, and then stop now is red. And then, no, I'm not sure what that is. These are the settings. This is edit, zoom in, zoom out, revert, differentiate, smooth, convert to counts, shift, depth profile, smooth, deconvolute, satellite subtraction, background subtraction, curve fit, atomic concentration, hardware settings, multiplier settings, gun properties, sputter. Okay, so just those icons. Once you know these icons, and we have a blog post that explains those as well. Once you learn the icons, it's just so much faster than going through the pull-down menus, in my opinion. Okay, then finally I said we talk about the help. The help no longer works because Microsoft stopped supporting their own help format. And this is something that we've used, again, going back into the 90s. So you can't really use the help. It won't work. Starting with Windows 8, it was hard, but by Windows 10, it was not working at all. It's no longer supported. However, we do have a blog post at RBD TechSpot where you can basically download and print out all the help. It's all saved as PDF files, so you can access that and print the entire help manual out if you want to have a help manual. Okay, that concludes our training on AugerScan.